I'm definitely going to stick to the name Thunder Meyer. It's definitely going to be a keeper. So my name is Matthias. I am currently CTO at Reaction Commerce, where we're building the open and open source commerce platform. Previously, I was one of the co-founders and the CEO at Travis CI, a company located here in Berlin, a continuous integration platform with a specialization for open source projects. I personally started out my career as an engineer, and hence I have a certain affinity for the technical aspects of continuous delivery, of shipping code to production, but also for open source, and business models around open source. And I also have an affinity for stories from other industries. So this talk is not a technical talk. I'm not going to talk about continuous delivery pipelines or these kinds of pipelines for that matter, or any technical topics. As much as I love the topics, you're welcome to talk to me afterwards about the technical sides of continuous delivery in any case. I want to talk more about the organizational aspects and the impact of continuous delivery. And for that, I want to tell a story, and it's a story about cars, where we're going back to my theme of liking to look at other industries. It's the year 1982, which means bad haircuts, but we're going to leave those aside for now. And we're at the NUMMI plant in Fremont, California. It's part of GM's network of production plants building cars, and it's also the production plant that was known for shipping the worst quality cars all over the USA. And not only that, it was also very famous or infamous for its workforce. It was known as the worst in the industry, and this is literally what the quote on the Wikipedia page says: the worst in the industry in the USA. People were drinking alcohol during shifts. They were deliberately sabotaging cars that left the production line and nobody cared, or they simply didn't show up to work. And every time the management, tried to change something about it, the unions threatened with strikes. So as you can imagine, that plant wasn't very productive, either because of strikes or because of absenteeism or because it just shipped a lot of cars that quickly made their way back into the plant and either had to be repaired or filed as, as we say in German, Monday cars that are irreparable, that just need to be, trashed. And so not surprisingly, the plant closed in 1982, the very year that we're in. This is fortunately not the part where my talk ends, because GM was thinking a little bit about what it could do with the plant. There were some ideas, and thankfully, they had a partner company to look to. They started a joint venture with Toyota, and Toyota, is a very, very popular car manufacturer to look at when it comes to lean manufacturing, continuous delivery, agile, all these things. They tend to root back. They tend all to move back to Toyota. Toyota at the time was facing potential import restrictions. So it was looking for a means to produce its own cars on US soil to avoid these restrictions. And so the ultimate goal of both of them working together was to produce high-quality cars at the lowest cost. And that's cars for both GM and Toyota. And for that, NUMMI adopted the Toyota production model. I'm going to talk about that a little bit. And the key thing here is the factory reopened in 1984, and it did so with 85% of the previous workforce. The previous workforce who were drinking alcohol during shifts, who didn't show up for work, and who deliberately manufactured faulty cars. The plant leadership thought that the system that these people were working in was bad, not that the workers were bad. So this is why they hired most of them. Just has the benefit of they didn't have to look for people who have the experience that these people already had. One thing I like about this article, presumably from '84, is that it talks about a startup, which is kind of what NUMMI was, because it was starting from a blank canvas. There was nothing. It started from scratch, like most startups do, or have the fortune to do, and just trying to figure out what works and how they can go to market with it. And so in 1984, in that same year, workers from NUMMI were sent to Toyota in Japan to work pretty much hip to hip with their counterparts. This is one of the actual people from the NUMMI plant working together at Toyota. So they worked hip to hip with their counterparts at Toyota, and they observed the Toyota way, which is pretty much, that can be distilled down a lot to a culture of collaboration and of continuous improvement, which is also where the famous Kaizen comes from. That's Toyota's way of continuously improving. The production plant teams at Toyota are really, really small. They're 4 to 5 people, and they even rotate jobs every couple of hours to avoid routine fatigue, so that they don't do the same jobs all over and over again. And after a while, routine sets in, and mistakes get made. So, switching jobs can be a nice way to avoid that, basically. And the team leaders only stepped in when there was a problem. And how did the teams let the team leader know that there was a problem? That happened using the end-on cord. Every person at the production plant could pull this cord, and this was the most unusual experience for the GM workers at the time. So whenever there's a problem, you pull the cord, production line stops, and the team leader steps in to help resolve the problem. Ideally, he doesn't have to, but the option is there. And something unusual happened there that the GM workers had never experienced before. As part of the resolution process, the team leader asked them, "What are your ideas for improvement?" Which is a question that nobody ever asked them back at their own plants at least before it closed in '82. And this is the key thing to Toyota's Kaizen in action. That culture of continuously improving, always looking for means of how you can improve the production process or avoid making that same, coming across that same problem that just now stopped the production line ever again in the future. And this is where a short stop in the production line can really lead to long-term improvements in quality, in efficiency, and in speed. And quality was really what Toyota was all about at the time, and still is, presumably. At GM, on the other hand, the production line never stopped, at least until '82 again, and presumably in most other GM production plants. The line never stopped. If you were behind on your post, it was your problem. Nobody came out to help you. There was no team leader to step in. If you were behind, you had to deal with it. You had to catch up again. And most of the time, people never did. And so, when the team was done with their stint at Toyota in Japan, they took their learnings back to the NUMMI plant. And within a couple of months of the first car, this very first car, rolling off the floor in '84, quality improved dramatically. And so did team spirit and the culture at the plant. Presumably, there was no one drinking anymore. The defect rate per 100 cars turned out to be the lowest in the USA. So we, just within a couple of months of changing the culture and the behaviors in the company, the plant churned out the highest quality cars in all of the US. And so the natural thing, and what GM initially set out to do, was to bring all of these learnings back to GM, as a whole, as the entire organization, ideally. As part of the NUMMI transformation, they sent 16 people, to the NUMMI plant to learn everything they can, to observe everything they can, and to eventually take all of those learnings back to other GM production plants. They were called the NUMMI Commandos, and there were 16 of them. And unfortunately, this is where the good part of the story ends. So far, so good, and it's been a couple of years. But once the commandos wanted to start, spreading the joy of the Toyota and the lean production culture to the rest of GM, they encountered nothing but resistance. Plant managers rejected the need for change. They rejected even very specifically the idea of stopping the production line because their bonuses were tied to cars rolling off the line, not to their quality. And GM leadership itself had no urgency or plan to bring about any changes across the entire organization, even though their market share declined slowly but continuously over the subsequent years. So the learnings from NUMMI mostly stayed at NUMMI. And fast forward to 1993, GM posted one of its biggest losses ever for the business year of 92, a solid $23.5 billion. And only now did someone feel the need for change. The board kicked out the old leadership and brought in new leadership. That leadership, the CEO at the time was called Jack Smith, started pushing for adoption of the NUMMI model across all plans of GM. And it kind of worked, but the changes were really, really slow. Turnaround at a single plant took maybe about up to 2 years, which is a really long time, and if you have a couple dozen of these, That's all, it adds up. The improvements did show, but they just took a really long time to materialize. And in the end, GM got swept up in the financial crisis of 2008, filed for bankruptcy in 2009. The US government bailed them out in one of the largest bailouts in US history. And GM pulled out of the joint venture as part of the recovery process. And so that left Toyota alone with NUMMI. The irony is that the GM that went bankrupt was doing a lot better than the GM that posted its big loss in 1992. In 2010, Toyota shut down the plant for good, and in the same year it was bought by Tesla, and it's now one of its main production plants and is only generally referred to as only the Tesla factory. So, the end. Not of my talk, but of this story. Unfortunately, nobody lived happily ever after. All of the people lost their jobs at NUMMI. And probably about 30,000 people at GM lost their job as part of the recovery process from going bankrupt. So let's take this back to software development, which is kind of what most of us do here, or why we're here. We're here because of open source software. NUMMI's transformation started on a very local level. It was one plant where they tried it out to keep the risk small and just have a nice playground for experimentation. But it took more than a decade to expand to all of GM, and only after really urgency demanded change, after the company posted its biggest loss ever at the time. The idea is you improve one piece and then over time spread it across the entire organization. It's even a sales strategy, land and expand. And this generally can be a good strategy. This can be a good beginning step for a transformation or a digital transformation, as many especially established or corporate companies are now going through or trying to go through. And it's a common way to look at engineering and software development as a local piece. As your first place to start in this kind of transformation. And the research even confirms this. The research says how a technology organization performs can predict overall organizational performance. This is from the book Accelerate, which is a book that distills 4 years of research from the State of DevOps survey, which I can highly recommend. The book also puts it quite differently. There's an alternative version of this quote. The more painful code deployments are, the poorer the culture. Or, to put all of this together, if your engineering teams can't deploy to production more than once a week, your company probably isn't doing so well. And so the ideal continuous delivery cycle, if we bring this back to the Crucible really, is this one. There's stuff is planned, stuff is coded, built, tested, released, deployed, operated, and then everything feeds back together. This is like the optimal continuous delivery cycle, which probably a lot here have seen already. But more commonly, each of these phases stretches out over weeks. We saw a great example earlier about the fast week, doing user testing in a very agile way that would fit in very well with this model, and distilling it down to a really, really short period of time. More commonly, though, each of these phases takes weeks. And it tends to be that each phase feeds an artifact into the next one, be it a build release or a product spec or a design or whatever it is. So all of these things can come into this process as well. So plan probably is more than a product spec or a requirement analysis. There's a lot more that goes into that one specifically. And so does release. There's probably a security team in there. There's maybe a Q&A team in there. There's the operations team in there. And eventually, hopefully, the features, new features handed off to customer support, who support it in production with their customers and eventually collect feedback that makes their way all the way back to the plan stage. At some point in the future, distant future, this is what I've seen more commonly than not, that cycle starts again. So going through this entire loop can take months for a certain type of organization. But if you can implement this kind of cycle in a really short period of time, you're probably on a good track. You're probably one of those high performers that the book Accelerate keeps talking about. I'll go into this in a bit. So takeaway here is this is a wonderful cycle. if you can do it in a relatively short period of time. But more often than not, the cycle in reality looks more like this. It reminds me a lot of the waterfall model whenever I see this implemented or whenever people explain to me how they're building and shipping their software. And I've seen this process across all kinds of organizations. There's no exception here for the type. This is not a process that's limited to larger organizations or organizations going through digital transformation. Startups do this same process, even though they have all the need in the world to be agile and fast-moving. It's a default to err to this kind of mode of working because it's comfortable and because it flows easily. Everything flows from one stage to the next. And if one stage fails, you can just go back to the previous one. And this process will deliver something to the customer eventually. But it's just a lot slower than an organization that's set up for speed and agility. And even when an engineering organization is managed to adopt the cycles that I showed earlier in a really short period of time, most of the organization is still left out. We have engineering over there, all in the water, and everyone else is stuck here on dry land, which is either they feel left behind, or they're wanting to keep the status quo, or they're just company leadership doesn't take them along, or what more commonly happens, these kinds of departments become a limiting factor. That engineering is suddenly a fast-moving organization, but everyone else is stuck with old practices. And I need to sip. And in scenarios like these, agile, continuous delivery, what have you, remains a local optimization, just with NUMMI and with GM. And these organizations tend to fall short to instill a really broad continuous delivery mindset. And we even have the metrics to show how much we focus on engineering. We have burn down charts, we have velocity, we have returns on investment, cumulative flow charts. There's probably a ton more agile metrics that I forgot here. But the key with these is that they all focus on output. An output can be a commit, a delivered story point, a line of code, a monetary expectation met, like a return on investment, or a task moved from backlog to in progress. And output metrics like these tend to tell the business that engineering is doing something. They're doing stuff, they're working, they're outputting stuff. But these metrics tend to have no indication about how fast they're really moving, even though we really would like velocity to tell us that, and how quickly they can deliver value to the customer. Now, if you want to, just to show you a few examples of what kind of metrics can do that, these are key indicators of high-performing teams and organizations. Again, backed by research from this very book. There's a lead time. Lead time means, how long does it take from a customer request, emerging on one side to it running in production on the other side. That's your lead time. The shorter that can be, the more high-performing and, by extension, the better doing your company is. Mean time to restore. If your site goes down, how quickly do your teams recover? Deployment frequency. Again, we come back to the earlier example. How often do your teams deploy to production? Is it once a week, once a month, once a quarter, or is it multiple times a day? And change fail percentage. How often does a change that you deploy to production break something? The key for these metrics is they don't focus on outputs. They focus on outcomes, which is what high-performance organizations do. And many organizations will keep existing in the mode of focusing on output only, especially in engineering teams, because engineering work can be really, really hard to grasp and even harder to measure, especially if you look at what has my team been doing. What these companies, again, have in common that they're more likely outperformed by their faster-moving competition who manage to instill a delivery mindset across the organization, not just in a localized part. And if there's one takeaway from NUMMI's and GM's demise, it's that continuous delivery starts at the top of the organization. And you can replace continuous delivery with agile, with lean, with a digital transformation. It really doesn't matter. If company leadership isn't fully behind it and driving it, the change will remain local. Toyota has the single goal of quality over quantity, which starts at the very top. It's very clear, an outcome-based, outcome-focused goal and vision. You can start with a local optimization and engineering team, like most organizations do. That's fine. It's a great idea. But if you don't spread the culture to the rest of the organization, it'll always remain a local optimization, just like with NUMI and GM. Thank you.
Yeah, Matthias.
And there's a lot more to read for you here.
Do you have any questions? Do I see any question marks above your heads? No question mark.
Ooh.
Ooh, wow.
So, not sure if that's good. But,
no, I think if every question is answered. So we hope that you had a lot of ideas out of this speech that you can share, because remember what Ingo said this morning, if you share data, if you share content, you have double content. And perhaps you allow me at this point to tell you that when you afterwards, stay here, but when you afterwards leave the Congress, there will be no bag with unnecessary and not funny things in it.